Hello, all you cats and kittens out there. I'm just kidding. Welcome to another Mr. Marcus's math tutorial videos. Today we're going to be talking about squares and square roots. Specifically, we'll be starting with perfect squares. A perfect square is a number in which when you multiply a number by itself, you get that as a result. Now that might sound complicated, but if you look at a multiplication table, all the perfect squares up to 81 are already on there. Any number times itself, like 1 times 1, 2 times 2, 3 times 3, are all going to result in perfect squares. So the first perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, and 81, because all of those are a number multiplied by itself. The numbers in red are called square numbers. These are called square numbers because they result in a square. If you think about an actual square, the sides are always the same. So if you look at an actual square and its length is, let's say, 10, that means its width is 10, and then to find the area of the square, 10 times 10 will give you 100. So let's do this first activity and calculate the perfect squares up to 15 squared. Notice the notation at the bottom with the exponent of 2. The exponent of 2, if you forgot, is referred to as squared. Now, in this case, we're going to write it as the exponent. But in the list we're about to make, we're not going to use those, but you can write it either way, it's up to you. So now, this list is going to be very important over the next several lessons. So I would suggest you either screenshot it and then paste it into Paint, pause the video and copy it down, but do something to make sure you have all of these numbers because you are going to need them, and it's a lot easier than doing it a bunch of times. If you look at the left side where I wrote 5 squared, that would be the same as 5 times 5. And all the perfect squares up to 15 squared were listed right there. So now in this next activity, we can use our list or calculations to figure out whether Roman numerals 1 through 6 are perfect squares or not. Now you might remember some of these may be on your list, but others were not. A square is the result of multiplying a number by itself. So 16 is a square because 4 times 4 is 16. 324 is a square because it's 18 times 18. And 729 is 27 times 27. The other 3, 15, 146, and 300, no number times itself equals those numbers. 5 times 3 is 15, but 5 and 3 are not the same number. So now we're going to think about the roots. You've already seen them. All the numbers that get multiplied by themselves are all roots of a square. It's the same as saying, what if it was the side length of a square? The original square I had you think about was a square of 100. Its side length was 10. That's the root. Now over here, we're looking at a square that has an area of 4 by 4. So the square on the left side is 16 square centimeters, or 16 centimeters squared, because each of the roots is 4. We write this as 4 is the square root of 16, using the square root symbol. If you look at the bottom of the screen right now, you'll see the square root symbol is outside of the 25. Some of you might be familiar with this term from earlier lessons. We may have called it a radical. But in the case that the radical doesn't have a number on the outside, that means that it's only asking for the square root. Any number multiplied by itself that results in another number is a square root. So now, we've talked about how to find the roots of perfect squares, which is just as simple as saying take a number and multiply it by itself only. But what if they were not perfect? Well, first we're going to start with a couple of perfect ones. In this case, we're asking for the square root of 25. Now that symbol in the front, known as a radical, if it doesn't have a number that in between the check mark part over there, it's simply saying square root, and the square root of 25 is determined by saying what times itself equals 25. So in this case, I know you figured out by now, that number is equal to 5. Now that's pretty simple, because every perfect square has an exact square root. If I asked you what the square root of 64 was, you might say, well, what times itself equals 64? Only 8 times 8. Although there are other ways to multiply to get 64, those are the only numbers that can be multiplied by themselves to make 64. So in this next example, it says the square root of 49 equals what? So now, there can be any number of ways to multiply to get 49. Not that there really are, but it doesn't matter. We're only looking for numbers that can be multiplied by themselves. So what number times itself, or you could look at your list, equals 49. That number is 7. But in the next example, what if the number wasn't one of the perfect squares? How would we then do it? Well, in this case, we're going to have to start using estimating. Estimating is the only way to get an estimate for a root of a non-perfect square. So in this next example, we have the square root of 27. Now you might start by saying, I know 9 times 3 equals 27. These numbers will not help you because 9 and 3 are not the same number, so they can't be the square root. Now you can say nothing times itself equals 27. Well, that's right. Nothing times itself equals 27. So that's why we have to use estimation. In this case, since 27 is not a perfect square, we have to use another method. Now we have to start thinking to ourselves, we do know numbers close to 27 that are perfect squares. We just saw one that was 25. Maybe that'll give us a hint as to the approximate square root of a non-perfect square, like 27. Not all numbers are perfect squares, and not every number has an integer, which means whole, positive or negative number, for a square root. So in those cases, we have to estimate square roots for numbers that are between perfect squares. So start thinking about what it means to be between mathematically. So to calculate the square root of a non-perfect square, you place the values of the adjacent perfect squares, and remember from earlier lessons, adjacent means next to, on a number line. So the number just above 27 and the number just below 27 that are perfect squares will help us. Now, if we wanted to figure out the square root of 62 without doing any calculations, you could just say which two consecutive roots is it between. So we know 62 is close to 64, that's above it, and then 49, that's below it. So we just need the square roots of 49 and 64, which are 7 and 8. So you could just say it's between 7 and 8. It's not exact, but it's what we have to work with. So what are the perfect squares on each side of 27? This number line can help you to estimate the root of a non-perfect square. The red numbers are showing perfect squares, but the black numbers are only there as identifying markers on the number line to let you know where the numbers lie. So now, 27 on this number line would be somewhere after 25, but before 36. It would be exactly 2 places past 25. If the square roots of those 2 numbers in blue there are 5 and 6, then it must be somewhere in between, but it's definitely closer to the 5, so we could estimate it as 5.2. That's sort of like a guess, but it's an educated guess. It's an educated guess that can be checked. If we do 5.2 times 5.2, we're looking for a number close to 27, but maybe not exactly. The answer comes out to 27 400ths, or 27.04. That's pretty close, and that's close enough. Remember to leave comments and questions in the section below. Also, you can reach me on Pupil Path with questions. Remember to complete the handout regarding squares, and keep watching for more and more exciting math videos.